Hi, I'm Professor D.K. Panda from the Ohio State University, together with my colleagues Professor Hari Subramani, Dr. Amir Safi, and Nauras Al Nashan. We are very excited to bring you this tutorial at Supercomputing 2023. It is titled Principles and Practice of Scalable and Distributed Deep Neural Network Training and Inference. If you know, we are in a very exciting world. The field of AI is changing quite a lot of things. And in that context, we are seeing a lot of developments taking place with respect to machine learning and also deep. Now, these concepts in the machine learning, deep learning are nothing new as of now, but they have been there, even as you can see here, almost from the last 100 years. But a lot of changes are happening with respect to networking technologies and especially HPC systems with CPUs, GPUs, and all. And that is actually helping us to really make strong progress in trying to provide newer kinds of solutions in the field of. Now, a lot of common examples you might be encountering in everyday's life, like a credit card fraud detection using on big kind of simulations, AI-driven simulations, generating arts by understanding the behavior of how the painters have been painting over the years, and even very simple examples of like a even the Google. Now, as these applications, the machine learning, deep learning applications are increasing in their size, obviously there is a need of parallel training. As you know, the language models like the ChatGPT and all have been continuously evolving with a very large billions of parameters. Same thing is happening with respect to vision models, and uh, and especially these kind of models require a lot of memory, a lot of computation, and even sometimes they cannot even fit a single GPU memory. So if you're just trying to utilize a single node servers or a CPUs or GPU or even a collection of GPUs within a single node, you may not be able to scale of the training of these applications, the models. So this is where the community has been moving into the multi-GPU training. And this is where there is a big significance these days with respect to multi-node distributed. And so in this context, you might be asking yourself, the questions, many of these questions like, can we understand the DNN training performance in a holistic manner? If I run it on multiple GPUs, how do I know that how much time it will be taking for my training as well as for inference? How I can correlate the low level performance to high level metrics? Can we utilize the existing HPC systems, the MPI runtimes, or if not, what additional changes need to do? And if the data is not fitting into the model and data is not fitting into a single GPU, then how I can handle out of code DNN, and what are the kind of the open issues at the intersection of DL and HPC, and especially the modern GPUs like from NVIDIA, AMD, and Intel, how to exploit these GPUs for machine learning and deep learning, and especially with respect to distributed training and inferencing, how I use that in the context of also the machine. So the broad challenge the community is facing these days is how to efficiently scale out machine learning and deep learning frameworks and take advantage of the heterogeneous high performance computing resources. So when we say heterogeneous, these are like the CPUs, GPUs, DPUs, and even IPUs, all these play. So to answer all these questions, we have put together an excellent tutorial. It's a full day tutorial. This is the kind of the outline. As you can see, we'll be starting with a very high level introduction, going over the machine learning, deep learning frameworks. We'll provide an overview of how these frameworks get executed. We'll take a look at the distributed machine learning algorithms, go into details of the deep neural network training and their principles. And then we'll try to see what is happening with respect to what are the needs of this data parallel training, how people are trying to do that, and bring you an overview of the high performance computing architectures. And then we'll try to combine these HPC technologies and for the machine learning and deep learning, and then go into the advanced distributed training. And we'll also be bringing out some distributed inferencing solution and how people can also utilize the high performance hyperparameter optimizations in this context. We'll talk about open issues and challenges, and then in addition to explaining the concepts in a theoretical manner. We have put together a set of very nice hands-on exercises. Here you will be actually working on a remote GPU cluster. We have, as you can outline, as the outline says, we'll be having 5 different labs, starting with a very different kinds of exercises. Distributed machine learning use cuML, to TensorFlow using Horobot. Then we'll try to do a distributed training for PyTorch using Horobot. Then we'll try to use also the different distributed training for language models using DeepSpeed. And the final lab will be on the distributed hyperparameter optimizations using DeepHyper. A lot of very interesting materials for you. So please join us. This tutorial will be held on Sunday, the 12th November. It is a full day tutorial from morning to the afternoon. And I hope you will be liking all these materials so that you can actually get much more experienced in this field of distributed and parallel training and inference. So we are looking forward to seeing you at the tutorial. If you have any questions between now and the conference, please feel free to send us questions using the email addresses indicated here. Thank you.